In this lecture, we'll take a look at how to create our own methods.
Now, it would be nice if all the predefined methods we're given to us are the only methods we're going to need. That would be the dream. But unfortunately, it's impossible to know every single method we're going to need. Yeah, sorry. There's not much we can do. But like most programming languages in Java, we are allowed to create our own methods. And these methods are called user-defined methods. And we can classify user-defined methods into one of two categories. We have value returning methods, and these are methods that have a return data type. So what do we mean by that? Well, these methods will return a value for some specific type using the return statement. So this is a special statement that's used in our methods that say we're going to run this method but send something back to whatever method called that method. So in our last lecture, a lot of the methods from the math class returned either an integer or a double. So these were value returning methods. We also have void methods. These are methods that just don't have a return data type. They just run some code, but they don't send anything back. And as I said, yeah, these methods they don't have a return statement. If they're not going to send anything back, there's no point in even having a return statement to even return a value. Our focus for today's lecture will be on value returning methods. Don't worry, we'll get to void methods. That's just be for another time. As I've already said, we've seen examples of value returning methods. So things like the PAL method, square root, is lowercase, to uppercase. All these methods are going to do some type of calculation, and then they're going to return a value to whatever method called that method in the first place. If we're going to develop our own value returning methods, there are certain things about the method we need to know. So we need to have the following properties figured out. We need to know the name of the method. We need to know the number of parameters, or even if there are going to be any parameters. We need to know the data type of each parameter. And we need to know the data type of the value that we're going to compute by the method. This is also the value that's returned. So whatever we do our computation is, this would be the value of the method itself. Now, the value that we return is usually unique. And once we've gotten our result, the value is used in one of three different ways. We can either save it for some future calculation, we can use it for some current calculation and just use it right away, or we can just simply print the value. So this means that we can use a value returning method in our expressions. So we haven't done this really at all just yet, but the point is, since our value or method is going to return some value, we can actually include methods in our expressions. Each method also includes the code that we need in order to accomplish our task. So we'll have to not only pass these, define these properties that we just talked about, but we also need to write up the code in order to accomplish that task. So by combining all these components of a method, we can break down a method into two parts. First, we have the heading of the method, and this contains the basic properties, the name, the parameters, the return type, and so forth. The body of the method contains all the code that's associated with the method. So these two parts combined form the definition of our method. So if we ever talk about the method definition, we're talking about the heading with all the properties and the code that gives us the actions that we have to take to run that method. Let's take a look at an example of a method definition, and we'll use the ABS method. So here's the complete definition. So let's take a look at the different parts. So the heading is going to be public static int ABS int number. So it's going to be this part right here. And notice that's the first line of our method. In fact, for any method definition, the heading is going to be the first line. It's just always going to be that way. The name of our method is going to be ABS. So the name is always going to be the word right before the pair of parentheses. So if you're looking for the name of the method, you can always look for it right before the parentheses. Now, any variable that we declare in the heading is what we call the formal parameter. So in this case, that's going to be number here. So number is going to be a formal parameter, and we can have however many parameters we want. It's just, think of it as a variable declaration inside the parentheses. And then the code that's between the curly braces, so this part right here, this is all considered the body of our method. So it's everything that's between the curly braces. The whole purpose of using methods is we want to have some piece of code that we can run whenever needed. So we just write this code once, set it off to the side, and then just say I want to use this code at this part of my program, and then maybe at this part of my program. That way we don't need to rewrite our code every time we want to use it. So the method definition does give us a way to set aside that code. It gives us the code that we need, and all we got to do is just say whenever we want to use it. So all we need now is just a way to tell the program that we want to use this code that's set off to the side. So this is what's called calling a method. So for example, let's say we use the pal method. So let's say the heading of our method is public static double pal, and then in parentheses we have double base and double exponent. In this case, the formal parameters here are going to be base and exponent. So let's now consider the following statements. Let's say we have this code. So here we're going to declare 5 different double variables where u has 2.5 and v has 3.0. And I call pal method 3 times. So we have the first one, the second, the third. And we see that the way we call a method is we include the name of the method, we have our pair of parentheses, and then values that we want to pass to our definition. So in our first statement, x equals pal uv, we take the values of u and v and we pass them or store them into base and exponent respectively. So in this case, we take u, which is 2.5, and that gets stored in base, and v stores 3.0, that gets stored in exponent. So when we run the definition of pal, we're using those values in base and exponent. So we say that u and v are examples of actual arguments. Some books will say like actual parameters, but just to make sure we don't confuse the term when calling and running methods, we're going to use the term argument here, where an argument is a variable or a value that is used in the method call. So the result here with this method call is we pass u and v, we use the base and exponent, we get our calculation, and we return some value, and that gets stored in x. And then we just run the same process for the other 2 method calls. So in y equals pal 2.0 and 3.2, we use the same code as our definition from before, except base now stores 2.0, and our exponent will store 3.2. And then we store that result in y. And then in our third method call, we have pal, we're going to pass the value of u, which is 2.5, so that gets stored in base. And then we pass the value 7, that gets stored in exponent. It does its calculation, so in this case it's going to compute 2.5 to the 7th power. It's going to send some result back, and we store that in w.